Hi students and welcome to this lecture. In a previous chapter we have studied all about trigonometry. What exactly is trigonometry, how to find the different trigonometric ratios, what are the trigonometric ratios for special angles, what are complementary angles and so on. Now in this chapter we are going to see about the applications of trigonometry. Why trigonometry is so important for us to study. So in this lecture we are going to see how trigonometry is applied in so many diverse fields of science. So let's look at some of the very basic applications of trigonometry in our day-to-day lives. Now, applications of trigonometry in the measurement of height of buildings, monuments, even that of mountains. So trigonometry is a field of mathematics which is involved in the measurement of heights of buildings, maybe monuments or even that of mountains. It is used to calculate the distances from the earth to the planets and stars. So trigonometry is used in calculating the distances from earth to the planets and the stars. We know that planets and stars are very far located from each other. But then how do we calculate the distances of such planets or stars or satellites from earth? This is done through the tool of trigonometry. It is also used in geography and in navigation. So navigators and geographers use the tool of trigonometry to find out some of the very important results, maybe distances, maybe longitudes, latitudes and so on. Even locating places involves the use of trigonometry. The knowledge of trigonometry is used to design maps, determine the position of an island in relation to the longitudes and the latitudes. So trigonometry is used to design maps. Now maps are the graphical representation of different points on a piece of paper. So trigonometry is a branch of mathematics that is very widely applied in determining the position of an island in relation to the longitudes and the latitudes, and also in the designing of maps. Some more applications are optics and statics are the two early fields of physics that use trigonometry. But all the branches of physics use trigonometry since trigonometry aids in understanding space. So whenever we talk of optics or the phenomena that take place in optics, we apply the knowledge of trigonometry over there. And also not just the optics and statics, trigonometry is used in almost all the branches of physics because trigonometry helps us in understanding space, and space is related to physics. So physics very widely involves the use of trigonometry. Calculus, linear algebra and statistics in particular use trigonometry and have many applications in all the sciences. So even in the fields of mathematics like calculus, linear algebra and statistics in particular involve the use of trigonometry and have many applications in all the other sciences. One more application is theodolites. Theodolites are mainly used for surveying applications and have been adapted for specialized purposes in the fields like meteorology and rocket launch technology. They are all based on the principle of trigonometry. So theodolites are mainly used for surveying and they have been adapted for specialized purposes like meteorology and rocket launch technology. All these are very complicated sciences and technology, and these all are based on the principle of trigonometry. So what we can say is trigonometry is a very important field of mathematics, and every science that you can imagine involves the application of trigonometry. So trigonometry plays a very important role in calculations. But in this chapter we are going to mainly focus on how trigonometry helps us to calculate heights and distances, maybe height of a mountain, height of a tower, or the distance between two buildings. So the application of trigonometry in calculating the heights and distances is our main point of discussion in this chapter. So we are going to see how trigonometry helps us in calculating the heights and distances of various objects. So before we start studying in detail, let's first try to understand the important terms used in heights and distance. The first is horizontal ray. Now what is a horizontal ray? A ray parallel to the surface of the earth emerging from the eye of the observer is known as horizontal ray. So a ray parallel to the surface of earth and that is emerging from the eye of the observer is actually known as a horizontal ray. So let us say that this is an observer and the ray that is emerging from his eyes and is parallel to the earth is known as a horizontal ray. So this ray is called as the horizontal ray, and it is emerging from the eye of the observer. The next is ray of vision. So ray of vision is the ray from the eye of the observer towards the object under observation is known as ray of vision or ray of sight. It is also known as line of vision or line of sight. So any ray from the eye of the observer to the object under observation is known as ray of vision. For example, let us say that this is a girl and this is her doll. Now this girl is viewing her doll. A ray from her eye towards any point of the object which is under observation is known as ray of vision. So this ray is known as ray of vision or ray of sight. Now let's see what is angle of elevation. If the object under observation is above the horizontal ray passing through the point of observation, the measure of angle formed by the horizontal ray and the ray of vision is known as the angle of elevation. If one is viewing an object that is above the horizontal ray and passing through the point of observation, then the measure of angle formed by the horizontal ray and the ray of vision is known as angle of elevation. So let us say that we have got any point A, which is actually the eye of the observer. Now let us say that we have another point P. P is, let us say, some point in the object and we have to view it. Now as per the definition, this would be a horizontal ray because it is emerging from the eye of the observer and is parallel to the ground. So this is known as horizontal ray. Similarly, a ray of light passing from A to P would be ray of vision. So this is horizontal ray and this is the ray of vision. Now from point P, let us drop a perpendicular on the horizontal ray. Now this becomes a right angle triangle. Now in this right angle triangle, if let us say that this is the angle formed between this horizontal ray and the ray of vision, then this angle is known as angle of elevation. So angle of elevation is actually the angle between the horizontal ray and the ray of vision when the object is above the horizontal ray. Here we see that P is above the horizontal ray. Angle of elevation is actually the angle made by the horizontal ray and the ray of vision. Now let's see what is angle of depression. If the object under observation is below the horizontal ray passing through the point of observation, then the measure of the angle formed by the horizontal ray and the ray of vision is known as the angle of depression. So here in this case, the object is below the horizontal ray and such that it is passing through the point of observation. Now the measure of angle formed by the horizontal ray and the ray of vision is known as angle of depression. Let us say that this is the eye of viewer. Now let us say that this is any point P under observation. Now this would be a horizontal ray because it is emerging from the eye of the observer and is parallel to the surface of earth. Similarly, this line would be ray of vision because it is emerging from the eye of the observer to the point under observation. So this is ray of vision. Now similarly, from P we drop a perpendicular PM on the horizontal ray. Now this is the angle between the horizontal ray and the ray of vision, and this very angle is known as angle of depression. So what we can say is angle of depression is the angle between the ray of vision and the horizontal ray when the point P is below the horizontal ray passing through the point of observation. So this point P is below the horizontal ray and therefore the angle of depression is the angle between the ray of vision and the horizontal ray. Now let's see the relation between angles of elevation and depression. Let us say that we have any point O and we have another point P. Now OP is the line of sight, P is the object under observation, and from this point we are observing this object P. From O we draw a line parallel to the surface of earth, so this becomes the horizontal line. Now if we say that O is the point of observation now and P refers to the eye of viewer, The line parallel to the surface of Earth and passing through P would be the horizontal ray. Now we see that this represents the angle of elevation, because for this case P is a point that is above the horizontal, and so the angle made by the line of sight, the angle made by the horizontal ray, is the angle of elevation. For the second case, when this becomes the object under observation, then this is the angle formed between line of sight and the horizontal ray, and so this is known as the angle of depression, because the object now is below the horizontal. So this is the angle of elevation and this is the angle of depression. Now what we see that OA and PP are two parallel lines and OP represents a transversal. Therefore these two become the alternate angles, and we know that alternate angles are always equal to each other. Therefore angle of elevation is always equal to angle of depression. So we see that angle of elevation is equal to the angle of depression. So always angle of elevation is equal to angle of depression. Whenever we are to find the angle of elevation, the point under observation is always above the horizontal, and when we are to find out the angle of depression, the point under observation is below the horizontal. So that's the basic difference between angle of elevation and angle of depression.